What if you could print in carbon fiber, stainless steel, or even sterling silver, without spending $10,000 on a specialized printer? The secret to unlocking your most ambitious projects isn't buying more gear. It's not another upgrade for your Ender 3. It's knowing exactly where to send your files to get them made by the pros. For years, I've seen fellow makers get frustrated by the limits of their desktop machines, warping, layer shifts, and a mountain of plastic spaghetti instead of their masterpiece. But there's a better way. In the next few minutes, I'm going to give you my personal list of the top 5 online 3D printing services designed for hobbyists right here in the USA. We're going to break down which service is the absolute best for getting miniatures with insane detail, which one is the cheapest for rapid prototyping your next great invention, and which one gives you access to mind-blowing materials you'd normally only see in an aerospace lab. By the end of this video, you'll have a roadmap to getting flawless prints every single time, saving you from headaches and wasted filament, and helping you bring your biggest ideas to life. So let's start with a scenario every single person with a 3D printer knows all too well. You've spent hours, maybe even days, perfecting a model in your design software. It's a custom bracket, a detailed miniature, a complex mechanical part. You slice it, you send it to your printer, and you walk away, filled with that unique mix of hope and anxiety. You come back 6 hours later only to find a plastic spaghetti monster, a warped base, or a layer shift that turned your masterpiece into modern art. It's frustrating, it's a waste of time, and it's a waste of expensive filament. This is the first great wall that every hobbyist hits, and it's where our number 5 pick for the best online 3D printing service becomes an absolute game changer. Coming in at number 5, we have JLC PCB. Now, if you've been in the electronics hobby space, you probably know that name for their incredibly cheap custom circuit boards. But what many people don't realize is that they've applied that same high-volume, low-cost manufacturing model to 3D printing, and the results are, frankly, astounding for a specific type of user. JLC PCB is not the service you use for a one-off museum-quality showpiece. This is your prototyping powerhouse. This is your personal, infinitely patient, and unbelievably affordable design assistant. Here's how it works and why it's so powerful. You go to their site, you upload your STL or step file, and within seconds their quoting engine spits back a price. The first time you do this, you will probably think it's a mistake. You'll see a price like 97 cents for a part that would have taken you 3 hours and $4 of filament to print yourself, and that's not even counting the electricity or the wear and tear on your own machine. The secret, of course, is economy of scale. They're running a massive factory with hundreds, if not thousands, of machines 24/7. Your tiny part is just one of a million pieces they're producing, so your share of the overhead is minuscule. This completely changes the way you design. Suddenly, you're not afraid to fail. That custom enclosure for your project? Don't just print one. Design 5 different versions with slight variations in the screw holes, the ventilation, the thickness. Upload all 5. The total cost might be less than $5. I had a personal project, a custom mount for a camera on a bizarrely shaped piece of equipment. I knew my first design wouldn't be right, so I designed 7 different versions, tweaking the angles by a few degrees each time. I uploaded all of them, had them printed in durable black ABS, and the entire order for 7 physical prototypes was under $10. The big catch? The shipping. And this is the crucial trade-off with JLC PCB. They are based in China, so shipping to the US isn't instantaneous and it isn't free. You're often looking at a shipping cost that's several times more than the cost of the parts themselves, and a delivery time of 1 to 3 weeks. This is why it's not for every project. If you need a part tomorrow, this is not your solution. But if you plan ahead, it's a strategic advantage. Here's the pro tip. Never order just one thing. Treat JLC PCB like a Costco run. You don't go for a single granola bar. You wait until you have a whole list. Keep a folder on your computer for parts to print. When you have 5, 10, or 15 different models ready to go, you upload them all in one batch. The shipping cost for a small box containing 10 parts is almost the same as for one, so you're effectively dividing that cost by 10. Suddenly, that $12 shipping fee becomes just over $1 per part, and the whole equation makes perfect sense. This service is for the iterative designer, the tinkerer who is constantly refining their ideas. It's for the person who needs to physically hold a part in their hand to see if it feels right. It frees you from the constraints of your own printer's speed and reliability, allowing your creativity to run wild without breaking the bank. For FDM printing, they offer the basics like PLA, ABS, and PETG, which cover 90% of hobbyist needs. But where they also shine is with their resin printing. Getting a super detailed resin print for just a couple of bucks is incredible, especially if you don't want to deal with the mess and fumes of a resin printer at home. So for sheer unapologetic bulk prototyping value, JLC-PCB is an indispensable tool in the modern maker's arsenal. But what if you can't wait 2 weeks? What if your 3D printer, the one you rely on, breaks down the day before you need a critical part for a project? What if you're going to a convention this weekend and you need a last-minute piece for your cosplay? The slow boat from overseas isn't going to help you. Your problem isn't cost, it's time. And for that, you need an entirely different kind of service. This brings us to our number 4 pick, CraftCloud. If JLC-PCB is like a single, massive, overseas factory, CraftCloud is like a nationwide marketplace. It's an aggregator. It's not a company that does the printing themselves. Instead, they partner with hundreds of different 3D printing services, big and small, all over the world, but with a heavy concentration right here in the United States. This fundamentally changes the value proposition. When you upload your model to CraftCloud, you don't get one price. You get a whole list of prices. You'll see offers from a print farm in Ohio using FDM, a specialist in California with high-end resin printers, and a shop in Texas that can print in exotic materials like nylon or carbon fiber composites. The interface lets you filter and sort by what matters most to you. And for the scenario we just described, you sort by one thing: speed. You can see estimated production and delivery times right there. You can often find a domestic supplier who can print your part and have it in the mail within 24 to 48 hours. With expedited shipping, you can literally go from a finished digital design to a physical part in your hand in just a few days. This is the emergency button. This is the save the project button. I have a friend who was building a custom drone for a racing competition. 2 days before the event, during a test flight, he crashed and snapped a custom-designed carbon fiber arm. His own printer couldn't handle that material, and no local service had it. He was about to give up. On a whim, he uploaded the file to CraftCloud. He found a specialized service in a neighboring state that could print it in Nylon X, a carbon fiber-infused nylon, and overnight it to him. The part was expensive, there's no doubt. It was probably 30 times the cost of getting a similar-sized part from JLC-PCB. But it arrived the morning of the competition. He fixed the drone and ended up placing third. That's the power of a service like this. You're not just paying for plastic. You're paying for speed, for access to specialized materials, and for the convenience of a domestic supply chain. The other huge advantage of a marketplace model is the sheer variety. Because you're tapping into the capabilities of hundreds of different vendors, the material selection is vast. You're not limited to the standard PLA, ABS, and resin. You can find people printing in flexible TPU, chemical-resistant ASA, high-temperature polycarbonate, and even full-color sandstone. If you've designed a part that requires a very specific engineering-grade material that your hobbyist-level printer could never handle, CraftCloud is almost certainly where you'll find someone who can make it for you. So who is CraftCloud for? It's for the hobbyist with a hard deadline. It's for the small business owner or Etsy seller who needs a reliable, US-based partner to fulfill orders quickly. It's for the advanced maker who has graduated beyond basic materials and needs access to professional-grade printing without spending $10,000 on a professional-grade printer. It's the polar opposite of our number 5 pick. One is a tool for patient, low-cost iteration, and the other is a tool for high-speed, high-stakes execution. They solve two completely different problems. So we have the ultra-affordable option for when time is on your side, and we have the lightning-fast domestic option for when the clock is ticking. But what if your project demands something else entirely? What if cost and speed are secondary to the single most important factor, jaw-dropping, flawless quality? What if you need a level of detail so fine, a surface finish so smooth, that it looks like it came out of an injection mold? For that, we have to look at a completely different technology and a service that has truly mastered it. The technology is called stereolithography, or SLA, and the service is Shapeways. Now, forget everything you know about melted plastic being squeezed out of a nozzle. Picture this instead. A tank, a vat, filled with the liquid photopolymer resin. It's like a clear, thick honey. From above, a high-precision ultraviolet laser, guided by a computer, dances across the surface of this liquid. And everywhere the laser touches, the liquid instantly hardens into a solid. The platform then lowers by a fraction of a millimeter. A layer so thin it's thinner than a human hair. And the laser draws the next slice of your model. Layer by tiny layer, your object isn't being built up. It's being grown, pulled out of the liquid like magic. The result? No visible layer lines. A surface finish that is astonishingly smooth. Details so crisp and precise you can see the pupils on a 28mm tall miniature's eyes. This is how you get injection mold quality from a 3D printer. And Shapeways doesn't just stop there. They also offer selective laser sintering, or SLS. This time, imagine a bed of superfine powder, almost like dust. It could be a durable nylon, a flexible TPU, or other engineering-grade materials. A powerful laser sinters or fuses the powder particles together again layer by layer. The incredible part about SLS is that the surrounding unfused powder acts as its own support structure. This means you can create impossibly complex geometries, interlocking parts, chainmail that actually moves, objects nested inside other objects, all printed as a single piece with no support marks to remove. But look, technical specs are boring. Let's talk about what this actually means for a hobbyist. Let's talk about Sarah. Sarah is a character designer, a digital sculptor who pours her heart and soul into creating these incredible fantasy creatures on her computer. For months she'd been working on her masterpiece. A griffin poised for flight, every feather individually sculpted, its talons sharp, its eyes fierce. She was so proud of the digital model. She tried printing it on her home FDM printer. The result was heartbreaking. The delicate feathers became a melted blob. The sharp talons were rounded nubs. The entire model was crisscrossed with ugly layer lines, and the support structures were a nightmare, breaking off half the details when she tried to remove them. Her art was getting lost in translation. All the nuance, the detail, the life she had sculpted into it was gone. She felt defeated. What was the point of spending 100 hours on a digital model if the physical version looked like a cheap toy? Then a friend in an online forum mentioned Shapeways. Sarah was hesitant. The website looked professional, almost corporate. The prices were, well, they weren't $4 for a kilogram of filament. A single print of her griffin was going to cost over $50. But she looked closer. She saw the material options: fine detail plastic, PA12 nylon, even precious metals like sterling silver and 14-karat gold. She read testimonials from other artists, jewelry designers, and miniature creators who had the exact same problem she did. They all said the same thing: it's worth it. So she took a leap of faith. She uploaded her file. The website software automatically checked it for printability, pointing out a couple of areas where the wing feathers were too thin and might break. That alone was incredible. It was like having an expert look over her shoulder. She made the adjustments, re-uploaded, and placed her order in their fine detail plastic, which uses a technology similar to SLA. Then she waited. The lead time was about 10 days, which felt like an eternity. She worried. Did she waste her money? Was it going to be another disappointment? The day the box arrived, she was almost afraid to open it. It was small, light, but professionally packed. She cut the tape, opened the flaps, and pushed aside the packing material. Inside, nestled in a small plastic bag, was her griffin. She carefully took it out, and she just stared. It wasn't a 3D print. It was her sculpture. It was real. Every single feather was perfect. The texture on the beak, the sharpness of the talons, the fierce intelligence in its eyes. It was all there. The surface was so smooth it felt like polished stone. There were no layer lines, no support marks. It was flawless. She held in her hand the physical object that, until now, had only existed in her mind and on her screen. And in that moment, $50 felt like the biggest bargain of her life. That's the Shapeways experience. You're not just buying a 3D print. You're buying the perfect realization of your digital creation. You're paying for access to machines that cost hundreds of thousands of dollars, operated by experts who know how to get the absolute best results from them. The material library is the core of their value. Want to design and print a custom engagement ring? You can do it in platinum. Want to make a set of durable interlocking gears for a custom robotics project? Their Nylon 12 is an industry standard. Want to create a full-color sandstone statue from a video game character model? You can do that too. This isn't just about making plastic trinkets. It's about making professional quality, end-use products. And there's another layer to Shapeways that is a potential game-changer for hobbyists. They have a marketplace. Once Sarah perfected her griffin model, she could open a shop on the Shapeways website. Now, anyone in the world can go to her shop page and order a print of her griffin. Shapeways handles the entire transaction. They print the model on demand, they package it, and they ship it directly to the customer. Sarah just sits back and collects a markup that she sets. She never has to buy a printer, touch any inventory, or deal with shipping labels. She can focus on what she loves creating, and Shapeways becomes her personal, global-scale manufacturing and fulfillment center. This transforms the hobby from a money sink into a potential source of income. Now let's be real. Shapeways is not for everyone or for every project. If you need a part tomorrow, this isn't your service. The lead times are longer because these are industrial processes, not desktop toys. And if you're trying to print a simple bracket or a phone stand, the cost is going to feel astronomical compared to your home printer. It's overkill. The cost is the biggest hurdle for most people. It requires a mental shift. You have to stop thinking in terms of cost per gram of plastic and start thinking in terms of cost per perfect outcome. How much is your time worth? How much is it worth to avoid the frustration of failed prints? How much is it worth to get a final product that looks and feels like it was commercially manufactured? For that one special project, the hero piece, the master copy for casting, the perfect gift, the prototype that will be shown to investors, the price becomes an investment in quality. So who is Shapeways for? It's for the artist, the sculptor, and the miniature designer who obsesses over detail. It's for the jeweler and the product designer who needs a specific material finish and property. It's for the entrepreneur who wants to sell their physical designs to a global audience without the overhead. It's for any hobbyist who has reached the absolute limit of what desktop 3D printing can do and is ready to graduate to the next level of quality. It's for when good enough simply isn't good enough. We've now seen the workhorse for engineers and the artisan's choice for creators. One is about function and speed, the other about form and flawless beauty. But what if you need both? What if your project is so complex, so ambitious, that you don't even know if it can be printed? What if you need more than just a printing service? What if you need a partner, an expert guide who can help you optimize your design for manufacturing from the very beginning? For that, we turn to our number one pick, a service that has built its entire reputation on tackling the impossible. Fictive. The name might not be as household as some of the others, but in the circles of serious engineers, product designers, and high-level creators, it's spoken with a certain reverence. Fictive isn't just an online 3D printing service. It's a digital manufacturing ecosystem. It's what happens when you take the concept of a print farm, inject it with Silicon Valley logistics, and wrap it in a layer of expert engineering support that is frankly unparalleled in this space. They've built their platform on one core idea: making hardware development as agile and fast as software development. And for the ambitious hobbyist, that changes everything. Imagine this scenario. You've spent the last 6 months designing a revolutionary new drone frame. It's your magnum opus. It's lightweight, aerodynamic, with complex internal lattice structures to save weight while maintaining strength. You've run simulations, you've tweaked every vertex in your CAD model. It's perfect. You upload it to a standard printing service. The quote comes back and your jaw hits the floor. It's 3 times what you budgeted. Or worse, the file is outright rejected as unprintable. You're stuck. All that work and you can't even get a physical prototype in your hands. This is the exact wall that Fictive was built to demolish. When you upload that same complex drone frame to Fictive, something different happens. Yes, you get a quote in seconds, but you also get an instant automated design for manufacturability, or DFM, analysis. This isn't just a simple wall thickness check. Fictive's platform, powered by sophisticated geometric analysis, acts like a seasoned manufacturing engineer looking over your shoulder. It might highlight a dozen potential issues you never even considered. It'll say, this internal support rib is too thin for MJF printing. It might warp during the cooling process. We recommend increasing its thickness by 0.4 millimeters. Or, this mounting hole is designed with a sharp internal corner, creating a stress concentration point. Adding a 1 mm fillet here would increase the part's fatigue life by over 200%. This is the game changer. It's proactive, not reactive. Instead of just failing your print and telling you to fix it, Fictive tells you why it might fail and how to fix it, often with specific, actionable recommendations. This feedback is free, it's instant, and it educates you, making you a better designer with every single part you upload. It transforms the process from a simple transaction into a partnership. You're not just buying a part, you're buying expertise. You're leveraging a system built on the data from millions of manufactured parts to de-risk your own project. So how does it all work? The magic of Fictive lies in its distributed network model. They don't own a single giant factory filled with printers. Instead, they have meticulously vetted and onboard hundreds of manufacturing partners across the United States. These aren't just random print shops. These are highly skilled, often specialized facilities with top-of-the-line equipment and rigorous quality control standards. When you place an order, Fictive's algorithm instantly matches your job, based on its complexity, material, and required lead time, to the perfect partner in their network who has the right machine, the right expertise, and available capacity. This model provides 3 incredible advantages. First, speed. Because they can tap into a massive decentralized pool of machines, they can offer lead times that are simply astonishing, sometimes as fast as next-day delivery for certain processes. Second, capability. Their network gives you access to a breathtaking array of technologies far beyond just hobbyist-grade FDM. We're talking industrial-grade SLS, high-resolution SLA, robust multi-jet fusion, and even CNC machining and urethane casting. As your projects grow in complexity, Fictive grows with you. You'll never outgrow their capabilities. Third, and most importantly for anyone who's ever been burned by an inconsistent supplier quality, Fictive stands as the single point of contact and the ultimate guarantor of quality. The part is made by a network partner, but it's made to Fictive's strict standards. They handle all the logistics, all the communication, and in many cases they perform inspections before the part is ever shipped to you. You get the quality and reliability of a single high-end manufacturer with the speed and scale of a massive distributed network. Let's look at a real-world case study. A team of college students was building an entry for a solar car challenge. They designed a custom, lightweight housing for their battery management system. It was a complex part with dozens of delicate features for ventilation and mounting. Their first quote from another service was not only expensive but came with a 4-week lead time, which would put them dangerously close to their competition deadline. Panicked, they uploaded the design to Fictive. The DFM feedback immediately flagged 2 areas where the wall thickness was below the recommended minimum for the durable nylon 12 material they needed. They made the suggested tweaks in their CAD software in under 10 minutes and re-uploaded. The new quote was not only more reasonable, but because Fictive's system could route the job to a partner with immediate MJF capacity, the lead time was just 5 days. They got the part, it fit perfectly, it was stronger than their original design, and they made their deadline with time to spare. That's the Fictive difference. It's not just about printing a file, it's about solving a manufacturing problem. Now it's crucial to set the right expectations. Is Fictive for everyone? No. If your goal is to print a handful of Dungeons & Dragons miniatures or a simple phone stand for the absolute lowest possible price, Fictive is probably overkill. Its premium service, expert oversight, and quality guarantee come at a premium price. You will almost certainly find cheaper quotes elsewhere for simple parts. Fictive is not competing to be the cheapest. They are competing to be the fastest, the most reliable, and the most capable. This is the service you turn to when the stakes are higher. It's for the serious hobbyist who is prototyping an invention they hope to one day bring to market. It's for the robotics builder whose parts absolutely cannot fail during a competition. It's for the creator who values their time and is willing to pay a bit more to avoid weeks of trial and error and failed prints. It's the ultimate accelerator. The cost isn't just for the plastic. It's for the peace of mind, the embedded expertise, and the speed that lets you iterate on your ideas at a velocity you simply can't achieve otherwise. Think of it this way: the other services sell you 3D prints. Fictive sells you manufacturing certainty. So to recap our number 1 pick, Fictive offers a potent combination of a massive, vetted US manufacturing network, industry-leading automated DFM feedback that makes you a better designer, and an unwavering commitment to quality and speed. It is the platform you graduate to when your hobby becomes a passion, and your passion starts to look like a profession. It's a true manufacturing partner that empowers you to build the impossible. So we've crowned our number 1. But this raises a crucial question. How do you actually choose between these 5 incredible options? What's the right service for printing a D&D mini versus a functional drone part? It's not just about which service is best overall, but which is best for your specific project. And that decision almost always comes down to one single critical factor that we haven't even touched on yet. That factor is the material. It sounds simple, almost too obvious, but the choice of what your part is physically made of is the single biggest fork in the road you will encounter. It dictates which services you can even consider, how much you're going to pay, and whether your final product will be a glorious success or a disappointing brittle paperweight. Think of it like cooking. You wouldn't use delicate pastry dough to build a gingerbread house, and you wouldn't use tough bread dough to make a flaky croissant. The ingredient defines the outcome. Let's start with the undisputed king of the hobbyist world, PLA, or polylactic acid. If you've ever seen a 3D printer at a library or a friend's house, it was almost certainly printing with PLA. It's the go-to for a reason. It's derived from renewable resources like corn starch, which gives it a slightly sweet smell when printing, a massive improvement over the hot plastic smell of other materials. It prints with incredible ease, requiring lower temperatures and no special heated enclosure, which makes it cheap and reliable for service providers to run. For you, the customer, this translates to lower costs and faster turnaround times. PLA is fantastic at capturing fine details. That D&D miniature we talked about, with its tiny chainmail links and the intricate filigree on its sword, PLA can handle that beautifully. It comes in a literal rainbow of colors, including wild variations like silky, metallic, wood-infused, and even glow-in-the-dark. But, and this is a huge but, PLA has an Achilles heel: temperature. It has a low glass transition temperature, which is a fancy way of saying it gets soft when it gets warm. Leave a PLA print in a hot car on a summer day in Arizona, and you might come back to a sad, warped puddle that vaguely resembles your original design. It's also relatively brittle. It can hold a lot of detail, but if you drop that D&D Mini, its tiny sword is likely to snap right off. So for decorative items, prototypes that won't be under stress, and things that live comfortably indoors, PLA is your best, most affordable friend. Now let's talk about the functional drone part. You would never ever make that out of PLA. The vibrations from the motors would shatter it, and the heat from the electronics could soften it mid-flight. For that, you need to step up to something tougher like ABS. That's acrylonitrile butadiene. And if that sounds like a mouthful, just think of Lego bricks. That's what they're made of. ABS is the old-school industrial workhorse of 3D printing. It's significantly stronger, more durable, and can withstand much higher temperatures than PLA. It's a true engineering-grade plastic. You can sand it, drill it, and even weld it together with acetone to create incredibly strong bonds. That drone arm made of ABS can take a beating, handle the heat, and keep flying. So why don't we print everything in ABS? Because it's a diva. It's notoriously difficult to print with. It needs to be printed at very high temperatures, and critically, it needs a heated, enclosed chamber to prevent it from cooling too quickly. If it cools unevenly, it warps and curls up off the print bed, ruining the entire part. It also releases some pretty potent fumes during printing, something service providers have to manage with proper ventilation. All of this adds complexity, cost, and a higher potential for failure, which gets passed on to you. So when you choose ABS, you're paying a premium for its performance. For years, hobbyists were stuck in this difficult choice. Easy, detailed, but brittle PLA or strong, durable, but difficult ABS. Then a new champion emerged to bridge the gap. PETG. That's polyethylene terephthalate glycol. Again, forget the name. Just think of a clear plastic water bottle. That's PET. PETG is a modified version that's perfect for 3D printing. It's the best of both worlds material. It's nearly as easy to print as PLA, but it's significantly stronger and more temperature resistant. It's also less brittle than both PLA and ABS, having a little bit of flex before it breaks. Many consider it to be the true successor to PLA for any part that needs to do more than just sit on a shelf. It's fantastic for mechanical parts, protective cases, and things that need a bit of impact resistance. It's also considered more food safe than other plastics, though you should always check the specific manufacturer's datasheet for that. The downsides? It can be a bit stringy during printing, leaving fine spiderweb-like hairs on the model that need to be cleaned up. It also doesn't bridge gaps as well as PLA, and can be more prone to scratching than ABS. But for a huge range of hobbyist projects, from a custom bracket for your garage to a functional gearbox for a robotics project, PETG is often the perfect sweet spot of price, performance, and printability. But what if detail is everything? What if the smooth, slightly ridged surface of a standard 3D print just isn't good enough? This is where we leave the world of squirting melted plastic out of a nozzle and enter the realm of light-cured resin. This technology, often called SLA or DLP, is completely different. It starts with a vat of liquid photopolymer resin. A high-precision laser or a UV projector shines a pattern onto the liquid, curing it one paper-thin layer at a time. The result? Mind-blowing detail. We're talking about details so fine you need a magnifying glass to see them. The layer lines that are a signature of FDM printing are virtually invisible. The surface finish is incredibly smooth, right off the printer. This is the technology you use for professional jewelry casting masters, dental models, and of course the most exquisitely detailed tabletop miniatures imaginable. Every tiny wrinkle on a wizard's face, every individual tooth on a monster's snarl, is captured perfectly. The trade-off is that these resins are often more brittle than even PLA. They can also be sensitive to UV light, becoming more brittle over time if left in the sun. The process is also messier, requiring a post-print wash in alcohol and a final cure under a UV lamp, steps that the service provider handles but which add to the overall cost. For hobbyists who demand the absolute highest level of aesthetic quality, resin is the only way to go. These four PLA, ABS, PETG, and resin are the big players you'll see on almost every online service. But the rabbit hole goes deeper. Want to print a phone case that's actually flexible and rubbery? You need TPU, a thermoplastic polyurethane. Want to print a set of custom gears for a high-stress application that won't wear down? You need nylon, possibly even a version reinforced with chopped carbon fiber for insane stiffness and strength. These specialty materials open up a whole new world of possibilities, but they also come with specialty prices and are not offered by every service. A service that excels at cranking out cheap PLA parts might not even have a machine capable of handling high-temperature carbon fiber nylon. This is why material choice is paramount. It's the first and most important filter you apply to your search. You don't just look for an online 3D printing service. You look for a service that can print an engineering-grade ABS, or a service known for high-detail resin. It immediately narrows the field from dozens of choices to just a handful of specialists. And this choice directly impacts the price. A simple 4-inch model might cost you $10 in PLA. The exact same file in PTG might be $15. In ABS it could be $25. In high-detail resin it could be $50. And in carbon fiber nylon, you could be looking at over $100 for the very same object. The geometry is the same, but the value and capability of the material completely transform the cost. So you've picked your project, you've zeroed in on the perfect material, you've got your 3D file ready to go. You upload it and suddenly the price is 3 times what you expected, or worse, you get an email saying your model is unprintable. What went wrong? It almost always comes down to the digital side of the equation, the hidden complexities inside your STL file that most people never even think to check. So let's pull back the digital curtain. When you create or download a 3D model, what you're usually working with is an STL file, which stands for stereolithography. Think of it as a digital blueprint made of thousands, or even millions of tiny interconnected triangles. These triangles form the skin of your object. In a perfect world, this skin is a single continuous sealed surface. It's watertight. Imagine your 3D model is a water balloon. If you could fill it with water and not a single drop could leak out, your model is watertight. The slicing software that prepares your model for the printer needs this. It needs to know with absolute certainty what is the inside of the model and what is the outside. The number one reason a file gets rejected is because it's not watertight. It has holes. It's a leaky water balloon. These holes can be microscopic, totally invisible to the naked eye, created by a tiny error in the design process. But to the computer, a hole is a hole. It looks at the file and can't figure out where the solid material is supposed to be. Another common problem is what's called non-manifold geometry. It's a scary-sounding term, but the concept is simple. Imagine in your model, you have a single edge that is shared by 3 or more of those little triangles. That's physically impossible in the real world. A real-world edge can only connect 2 surfaces. When the software sees this, it throws up its hands in confusion. It's like a blueprint for a house where one wall is simultaneously the interior wall for 2 different rooms. Doesn't make sense. Then you have the issue of flipped normals. Every one of those tiny triangles has a direction. It has an outside and an inside. These are called its normals. If some of these triangles get flipped around during the design process, you end up with a model that has patches of its skin facing the wrong way. It's like you're trying to build a sculpture, but some parts of the instruction manual are telling the printer to build the object inside out. The printer can't resolve this contradiction, and you get a failed print or a rejected file. And finally, there's the most common mistake for beginners: wall thickness. You might design a beautiful, intricate miniature with a flowing cape. On your screen, that cape looks amazing. But in the digital world, that cape might only be a single surface with no actual thickness. Or it might be so thin, say a fraction of a millimeter, that no 3D printer on Earth could possibly create it. The plastic or resin would just turn into a stringy mess. Every printing technology, whether it's FDM, SLA, or SLS, has a minimum feature size and a minimum wall thickness it can reliably produce. If your model dips below that, it's unprintable. So you're sitting there with a potentially broken file. Do you have to go back to school for a degree in 3D modeling? Absolutely not. You just need to know about the digital first aid kits that are available, and most of them are completely free. This is the pre-flight check that separates the amateurs from the pros, and it will save you so much time, money, and frustration. Your first line of defense, and one that's shockingly overlooked, might already be installed on your computer. If you're using Windows 10 or 11, you have an app called 3D Builder. Most people dismiss it as a toy, but its model repair algorithm is incredibly robust. You can open your STL file in 3D Builder, and if it detects any problems, a little red box will appear at the bottom, offering to repair the model. Clicking that one button can often fix 90% of common issues like small holes and flipped normals. It's a fantastic one-click sanity check before you upload anything. For more stubborn problems, you need to bring in the specialist, and that specialist's name is MeshMixer. It's a free piece of software from Autodesk, the same company that makes high-end programs like AutoCAD and Fusion 360. MeshMixer is like a Swiss Army knife for 3D models. When you import your model, the single most powerful tool is under the Analysis tab, called Inspector. When you run the inspector, it scans your entire model and puts little colored markers on every single error it finds. Blue markers for holes, red for non-manifold edges, magenta for other oddities. Better yet, it has an Auto Repair All button that does a remarkable job of patching everything up. For most models, this is all you'll ever need. You import, inspect, auto repair, and then export the new clean STL file. But MeshMixer can do more. What about that wall thickness problem? It has a tool for that too. Under the same analysis menu, you can find thickness. This tool will generate a color map of your model, showing you exactly which areas are too thin based on a minimum thickness you can specify. If your chosen printing service says they need a minimum wall of 1 mm, you can plug that in and instantly see the problem spots in red. From there, you can use MeshMixer's sculpting tools to gently inflate or thicken those areas until they're printable. Now, if you're looking for the ultimate free tool, and you're willing to invest a little time in learning, the answer is Blender. Blender is a professional-grade, open-source 3D creation suite that can do literally everything from animated movies to video games. But for our purposes, it has an incredible set of tools for model repair. It comes with a built-in add-on called the 3D Print Toolbox. Once you enable it, you get a special menu that is designed specifically to diagnose and fix models for printing. It can check for overhangs that might need support, find and select all non-manifold geometry, and report back on wall thickness. The learning curve is steeper than 3D Builder or MeshMixer, but mastering the basics of model repair in Blender is a skill that will pay dividends for your entire hobby. So let's put it all together. Here's your new workflow, the professional process that will ensure your files are perfect every time. Step 1. Finish your design or download your model from a site like Thingiverse or My Mini Factory. Step 2. Before you even think about uploading it to a service, open the STL in Windows 3D Builder. If it offers to repair, let it. This is your quick and easy first pass. Step 3. For a more thorough check, open the file in MeshMixer. Run the inspector, auto repair any issues, and then run the thickness analysis to make sure everything is robust enough to print. Step 4. Export this newly repaired, validated file. This is the file you will upload. By taking these extra 5 to 10 minutes to prepare your digital file, you fundamentally change your relationship with online printing services. You are no longer just rolling the dice and hoping for the best. You are submitting a clean, professional, verified blueprint. This means their automated quoting systems will give you an accurate price, because the volume calculation won't be confused by holes or weird geometry. It means your file will pass their automated checks and won't get kicked back to you with a confusing error message. And most importantly, it means the final physical object you get back in the mail will be exactly what you envisioned, with no missing pieces, strange surface artifacts, or catastrophic failures. You've controlled the digital variable, which is the one part of the process that is entirely within your power to perfect. Now that you know how to forge a perfect digital blueprint, the question becomes, which forge should you send it to? There are dozens of services out there, each with its own strengths, weaknesses, materials, and pricing. So let's start our top 5 countdown with a true giant in the industry, a name that's been in the game for over a decade, and is almost synonymous with online 3D printing for creators and hobbyists. This is the service that, for many, was their first introduction to the magic of turning a file into a physical thing. So let's dive into our number 2 pick, Shapeways. To understand Shapeways, you have to understand that they weren't just another company jumping on the 3D printing bandwagon. In many ways, they helped build the wagon. Founded way back in 2007, they were a beacon for designers, artists, and engineers long before desktop 3D printers became a common household item. They built the bridge for people who had incredible ideas locked away in a 3D file, but had absolutely no way to bring them into the real world. Their mission was, and still is, to provide access to industrial-grade manufacturing technologies for everyone. And that word, access, is the absolute key to understanding the power of Shapeways. It's not just a place to get a PLA print. It's a gateway to a universe of materials and processes that are simply out of reach for 99.9% of hobbyists. This is the service you turn to when your ambition outgrows the capabilities of your Ender 3 or your Elegoo Mars. The core of the Shapeways experience is their staggering material library. It's less like a menu and more like an encyclopedia of modern manufacturing. We're talking over 90 different materials and finishes. You can upload a single file and instantly see what it would cost to print in everything from simple, versatile plastic to precious metals like 14-karat gold, platinum, and sterling silver. Imagine that. You, a hobbyist designer, can create a custom piece of jewelry on your computer in the afternoon and through Shapeways, have it cast in solid, polished silver using the same lost wax casting methods that high-end jewelers have used for centuries. That's a level of creative empowerment that was unthinkable just a couple of decades ago. Let's talk about some of their standout materials for hobbyists. First, their nylon 12, which they call versatile plastic. This is their workhorse. It's produced using a technology called selective laser sintering, or SLS. Instead of laying down melted plastic layer by layer, SLS printers use a powerful laser to fuse together particles of nylon powder. The result is a part that is incredibly strong, durable, and slightly flexible, with a distinctive, slightly grainy matte finish. It doesn't have the visible layer lines of a typical FDM print, making it perfect for functional parts, interlocking pieces, drone frames, custom enclosures for electronics, anything that needs to withstand real-world stress. And because it's printed in a bed of powder, you don't need to worry about support structures, which allows for incredibly complex, intricate geometries that would be a nightmare to print on a home machine. Then you have their fine detail plastic. This is for the miniature painters, the tabletop gamers, and the sculptors who obsess over the tiniest details. Using industrial-grade material jetting and UV curing technologies, similar to high-end resin printing, they can produce parts with a level of sharpness and precision that is simply breathtaking. We're talking about capturing the texture on a piece of armor, the subtle expression on a 28mm scale face, or the delicate filigree on a model piece. The material comes in various finishes, and its smooth surface is a fantastic canvas for painting. This is how you get professional quality miniatures and display pieces without investing thousands in your own top-tier resin printing setup and dealing with all the fumes and cleanup. But where Shapeways truly enters a league of its own is with metals. Let's say you've designed a custom belt buckle, a unique pendant, or a replacement metal knob for a vintage piece of equipment. You can get it printed in materials like steel, aluminum, brass, bronze, and silver. Their steel, for example, is a fantastic option. It's not printed directly from molten steel. Instead, they use a binder jetting process where a steel powder is bound together, printed layer by layer, and then infused with bronze. This creates a final part that is incredibly strong, has a satisfying heft, and a beautifully rugged, slightly pitted texture. It's not machine shop perfect, but it has an incredible character and is shockingly affordable for a custom metal part. It's perfect for things that need to look and feel substantial. The user experience on their site is a reflection of this industrial power. You upload your model, and their software performs a suite of automated checks. It analyzes wall thickness, checks for loose geometry, and ensures your model is actually printable in the material you've selected. This is a lifesaver. Catches potential failures before you ever spend a dime. Then you get your instant quote. And this is where new users often experience some sticker shock. Shapeways is not the cheapest service on our list. Not by a long shot. The price you see is a complex calculation based on the volume of material used, the machine space your part takes up, and a per-part handling fee. A small, intricate nylon part might be surprisingly affordable, while a larger, solid steel piece could run into the hundreds of dollars. But you have to reframe your thinking. You're not paying for raw material. You're paying for access. You're renting time on a $500,000 SLS machine or a state-of-the-art wax casting facility. You're paying for the expertise of the technicians who operate and maintain that equipment. When you look at it that way, the pricing starts to make a lot more sense. It's the difference between buying a bag of flour and hiring a master baker to create a wedding cake. So who is Shapeways for? It's for the ambitious hobbyist, the creator who is pushing boundaries. It's for the jewelry designer who wants to prototype and sell their own line without investing in casting equipment. It's for the scale modeler who needs a one-of-a-kind part with impossible detail. It's for the engineer building a functional prototype that needs to withstand real mechanical stress. It's for the artist who wants to create a sculpture in polished bronze. Shapeways is the service you graduate to. Now, it's not perfect. The sheer number of options can be overwhelming, a classic case of paralysis by choice. The lead times can also be significantly longer than other services. A simple plastic print might take a week or more, while a cast metal part could take several weeks. This is a result of their batch-based manufacturing process. They need to fill up an entire industrial machine before running a print job to keep costs down. So this is not the place to go if you need a part tomorrow. But perhaps the most powerful and often overlooked feature of Shapeways is its integrated marketplace. Once you've perfected a design, you can open your own shop directly on the Shapeways website. You set the markup, and when someone buys your product, Shapeways handles the printing, the packing, the shipping, and the customer service. You just upload the file and collect the profit. This transforms the platform from a simple service bureau into a potential business incubator. For thousands of creators, Shapeways isn't just a tool. It's their storefront, their factory, and their fulfillment center all rolled into one. In the end, Shapeways earns the number 2 spot because it represents the pinnacle of access and possibility for the individual creator. It's a testament to the idea that a great design deserves to exist in the perfect material, regardless of whether you have the tools to make it yourself. It's more expensive and it's slower, but it offers a gateway to a level of quality and material diversity that can fundamentally change what you think is possible to create from your own desk. It's the ultimate enabler for turning high-end, ambitious digital dreams into tangible physical reality. It's an incredible platform, a true giant in the industry. But there is one service that, for a very specific and very large segment of the hobbyist community, manages to do something even more remarkable. It combines accessibility, speed, and a revolutionary approach to pricing that has completely changed the game. That service is our number 1 pick, is ProtoForge. Now, before you rush to open a new tab, let me explain why this service isn't just another name on a list, but a fundamental shift in how we, as hobbyists, can bring our ideas to life. ProtoForge didn't just enter the market. They looked at the entire landscape of online 3D printing, identified the single biggest point of friction for the individual creator, and built their entire company around solving it. That point of friction? The tyranny of the per-part pricing model. For years, the system was broken for us. Let's be honest. You design a project, maybe a custom case for a Raspberry Pi, a set of miniatures for a board game, or the components for a small robot. You didn't just need one part. You needed 10, 20, sometimes 50 small, intricate pieces. You'd go to a traditional service, upload your first file, and get a quote. $7. Okay, not bad. Then you upload the second file. Another $5. Then the third, the fourth, the 10th. Suddenly, your $20 project is costing you $150, plus shipping. The economics were tailored for businesses ordering a single large prototype, not for hobbyists building a complex assembly. It was a barrier, a wall that kept countless projects locked away as digital files on a hard drive, never to become real. ProtoForge saw this, and they didn't just tweak the formula. They threw the entire book out the window. They introduced a concept that is so simple, so brilliant, it's astonishing no one had perfected it for the US market before. The digital build plate. Here's how it works. Instead of charging you for each individual part, ProtoForge charges you for a standardized, fixed volume of space on one of their printer's build plates. Think of it like buying a small flat-rate shipping box but for 3D printing. You pay one single, upfront, incredibly reasonable price, let's say $25, for a virtual space of 150 by 150 by 150 millimeters. And here's the magic. You can cram as many of your own, unique parts into that digital box as you can possibly fit. Let's rerun our robot project scenario. You have 42 separate components. Gears, brackets, sensor mounts, leg segments, all different shapes and sizes. With the old model, you're looking at a build that would make you abandon the project entirely. With ProtoForge, you open their web interface, which looks like a simple video game level editor. You drag and drop your 42 files onto the virtual build plate. Their software, which they call the Nest, automatically analyzes and arranges the parts, rotating and interlocking them in the most space-efficient way possible, like an expert playing a game of Tetris. It shows you right there, in real time, all your parts fitting neatly inside that 150mm cube. The price doesn't change. It's still $25 for everything, for all 42 parts. This isn't just a pricing gimmick. It's a complete psychological and creative liberation. Changes the way you design. You no longer have to ask, can I afford to print this extra bracket? Instead, you ask, how can I design my parts to fit more efficiently in the box? It encourages smarter design. It encourages you to print spares. Got a little extra room in your build plate after adding all your robot parts? Throw in that phone stand you've been meaning to print. Add a few cable clips for your desk. Print that little figurine for your kid. As long as it fits, it's included. The cost is fixed. This single innovation has unlocked a level of creativity and project scale for the average person that was previously unthinkable. But a revolutionary pricing model is useless if the quality is poor or the process is slow. And this is where ProtoForge truly solidifies its #1 spot. They've built their infrastructure on what can only be described as massive optimized scale. They operate enormous print farms in the Midwest, not with 100 different types of printers, but with thousands of identical, perfectly calibrated workhorse machines. By standardizing their hardware, they've eliminated countless variables. Every machine is a known quantity. Every print is predictable. This factory-like approach allows them to offer a curated, but excellent selection of materials. You won't find 87 shades of exotic, wood-infused, color-changing PLA. What you will find is high-quality, engineering-grade PLA+, PTG, and ABS in core colors like black, white, and gray, the materials that 95% of hobbyists use for 95% of their projects. They focus on doing the essentials perfectly, rather than doing everything mediocrely. The result is parts that are strong, dimensionally accurate, and incredibly consistent from one order to the next. And the speed is just staggering. Because their entire system is based on filling build plates to maximum capacity, their printers are always running. They aren't waiting for your small individual order. Your digital build plate is simply added to a queue. And as soon as a machine frees up, your entire batch of parts starts printing. This insane efficiency means their standard turnaround time, from you clicking order to your box being sealed and labeled for shipping, is often less than 48 hours. They've streamlined the entire workflow, from automated file verification to robotic part removal and sorting, to a point where human hands only get involved for the final quality check and packaging. Now, it's crucial to talk about the trade-offs because no service is perfect for everyone. If your project requires a highly specialized material, like a medical-grade biocompatible resin or a super high-temperature PEEK thermoplastic, ProtoForge is not the service for you. Their strength lies in their focused, curated selection. If you need a specific Pantone color match for a commercial product, you'll have to look elsewhere. Furthermore, if you are an engineer developing a satellite component where every micron of tolerance is critical and requires pages of certification documentation, you'll want a specialized industrial prototyping bureau. ProtoForge is designed for the hobbyist, the maker, the inventor, the cosplayer, the tabletop gamer. It is for us. It's for the person who needs functional, durable, great-looking parts without the complexity and cost of the industrial world. It's for the person who values speed, simplicity, and an economic model that respects the nature of our projects. What they've built is more than a printing service. It's an ecosystem. Their interface includes tools that teach you how to design for manufacturability. They have a massive, searchable community library of pre-packed build plates that you can use as templates. Want to print a full set of chess pieces? Someone has probably already figured out the most optimal way to pack them into a single build plate, and you can use their layout with a single click. They've taken the guesswork, the financial anxiety, and the logistical headaches out of the equation. All that's left is your idea. They've effectively lowered the activation energy for creation. That project you've been dreaming of, the one that seemed too complex or too expensive to produce. ProtoForge puts it within reach. They've successfully democratized small-scale manufacturing for the individual in a way that no one else has quite managed to do. They don't just print your parts. They empower your entire creative process. And that is why they are, without a doubt, the #1 online 3D printing service for hobbyists in the USA. But what if your needs are different? What if you don't want to just print plastic but metal? Or what if you want to go beyond printing and actually sell your creations? That brings us to a fascinating and vital part of this ecosystem, the kind of platform that bridges the gap between a basement tinkerer and a global manufacturer. And topping our list, the #1 service that embodies this evolution is Shapeways. Now, to understand why Shapeways is in the top spot, you have to understand the journey of a hobbyist. You start with a simple printer making plastic trinkets. It's magic. But then your ambition grows. You design a beautiful, intricate pendant, but printing it in plastic just feels cheap. You design a critical replacement part for a vintage motorcycle, but PLA plastic is going to shatter the moment you start the engine. You dream of selling your unique Dungeons & Dragons miniatures to a global audience, but the idea of printing, cleaning, packing, and shipping hundreds of tiny figures from your apartment is a logistical nightmare. This is the wall that almost every serious hobbyist hits. It's the gap between imagination and reality, and Shapeways was built to shatter that wall. Founded back in 2007, they were one of the true pioneers, born from a simple, powerful idea. What if anyone anywhere could have access to the world's most advanced manufacturing technology? Not just giant corporations, but artists, engineers, and everyday creators. They didn't just build a print farm, they built a gateway. When you upload a model to Shapeways, you're not just sending it to a bank of desktop printers. You're tapping into a global network of industrial-grade machines that can work with a staggering array of materials. And let's talk about those materials, because this is where the game completely changes. We're not just talking about a few different colors of plastic. We're talking about over 90 different materials and finishes. Let's start with the plastics. You have your standard versatile plastic, which is nylon 12, printed using selective laser sintering, or SLS. This isn't the brittle layered plastic from a home printer. This is tough, slightly flexible, and perfect for functional parts, drone frames, phone cases, anything that needs to withstand some real-world abuse. Then you have the high-detail resins, materials like fine detail plastic. This is for the artists, the miniature makers, the jewelers. It captures microscopic details, creating surfaces so smooth you can't even see the print lines. It's the choice for creating master patterns for casting, or for producing final quality figurines that look like they were traditionally sculpted. But the real magic begins when you leave the world of polymers behind. This is what we hinted at. Metal. Shapeways offers an incredible range of options. You can get your parts printed in stainless steel using a binder jetting process, where a binding agent is printed onto a bed of metal powder, which is then sintered in a furnace to create a solid, strong metal part. It's perfect for things that need serious durability, custom tools, mechanical components, or jewelry with an industrial aesthetic. Want something more refined? They offer lost wax casting for precious metals. You can upload a design for a ring, and they'll first print a perfect high-resolution wax version of it. That wax model is then used to create a mold for traditional casting in materials like polished brass, bronze, sterling silver, 14-karat gold, even platinum. Think about that. You, from your laptop, can design a custom engagement ring and have it cast in actual platinum, a process that was once the exclusive domain of high-end jewelers. And it doesn't stop there. They offer materials like sandstone, which can be printed in full, vibrant color, making it perfect for architectural models, medical visualizations, or personalized avatars from a video game. The result is a ceramic-like, slightly gritty texture that feels substantial and looks incredible on a shelf. This breadth of materials transforms the very nature of what you can create. That replacement motorcycle part can now be made in steel. That beautiful pendant, it can be cast in sterling silver. Your hobby is no longer limited by the physical substance you can melt in your garage. This alone would be enough to put Shapeways in the top tier, but it's only half of the story. The other half is what truly makes it our #1 pick: the integrated marketplace. Shapeways understood that many creators don't just want to make things for themselves. They want to share them with the world, and maybe even build a business. But the friction of starting a physical product business is immense. You need inventory, packaging, a shipping station, you have to handle customer service, payment processing. It's a full-time job. Shapeways removes all of that friction. Here's how it works: you finalize your 3D model. You upload it to Shapeways. You run it through their automated printability checks. Then, you open a shop on their platform. For each material you want to offer your product in, you set your own markup. Let's say the base cost to produce your miniature in high-detail resin is $10. You can set a markup of, say, $15, making the final retail price $25. Now, you publish it to your shop. That's it. Your work is done. When a customer anywhere in the world finds your design and buys it, Shapeways system kicks in. They handle the payment. They manufacture the product on demand, meaning you never have to pay for inventory that doesn't sell. They inspect it for quality. They package it professionally, and they ship it directly to the customer. At the end of the month, they send you your profit. You become a global product designer without ever touching a shipping label or a roll of bubble wrap. This model has empowered an entire generation of micro-entrepreneurs. Think of the tabletop gaming designer who creates a whole line of custom monsters. They can sell them in multiple sizes and materials, catering to both painters who want a high-detail resin model and players who just want a durable plastic version. Or consider the mechanical engineer who designs a clever upgrade for a popular coffee machine. They can sell that part, printed in food-safe nylon, to coffee lovers everywhere. They're not just a hobbyist anymore. They're a business owner, a brand. Shapeways becomes their personal, on-demand factory and fulfillment center. Now it's crucial to be realistic. This power comes with trade-offs. The first and most obvious one is cost. Shapeways is not a budget service. Printing a part in steel or silver is, unsurprisingly, going to be significantly more expensive than printing it in plastic on a cheaper service, let alone at home. You are paying a premium for access to industrial machines, a vast material library, and rigorous quality control. It's not for cheap prototypes. It's for premium final products. The second trade-off is lead time. Industrial manufacturing processes take time. Sintering metal, casting gold, even processing large batches of nylon prints can take days or even weeks. This isn't Amazon Prime. You have to plan ahead. You're trading instant gratification for a level of quality and material access that is simply unattainable for a hobbyist otherwise. So who is Shapeways for? It's for the ambitious creator. It's for the hobbyist who has graduated from simple tinkering and wants to produce a professional-grade, finished product. It's for the artist who wants to hold their digital sculpture, cast in real bronze. It's for the designer who sees a market for their invention and wants to start a business with zero inventory risk. It's for anyone who has ever looked at a 3D model on their screen and thought, I wish this was real and made of metal. Shapeways is the service that says, it can be. It represents the ultimate potential of this technology, not just as a tool for making things, but as a platform for launching dreams. So we've seen the big players, from the budget-friendly and lightning-fast PCBWay and JLC PCB, to the community-driven network of hubs, the user-friendly simplicity of CraftCloud, and now the industrial powerhouse and marketplace of Shapeways. Each one is a fantastic tool, but they're designed for very different jobs. But how do you actually choose? How do you avoid wasting money on the wrong service for your specific project? In the final part, we're going to break it all down with a simple decision-making framework that will put you on the right path every single time. So let's build that framework. Forget complicated spreadsheets and analysis paralysis. We're going to use what I call the hobbyist compass. It's not about finding the one best service. It's about finding the one right service for the project sitting on your hard drive right now. The hobbyist compass has 3 main points: fidelity, function, and finance. Every single 3D print you ever order will be a balance of these 3 things. Get this balance right and you'll feel like a genius. Get it wrong and you'll end up with a box of expensive, useless plastic. Let's start with the first point, fidelity. This is all about the looks. How detailed does your part need to be? Are we talking about a simple blocky bracket where looks don't matter at all? Or are we talking about a tabletop miniature with intricate armor, facial expressions, and textures that need to be flawless under a coat of paint? This single question immediately splits our 5 services in half. If your answer is maximum detail is everything, you are immediately pushed toward services that specialize in resin printing, or SLA and DLP. You're looking at Shapeways and Sculptio. These services built their reputation on producing beautiful, gallery-worthy objects. Their high-resolution resin printers can capture details smaller than a human hair, leaving you with a surface so smooth, it barely looks printed. For sculptors, character artists, and miniature painters, this is non-negotiable. Using a standard FDM printer for a high-poly ZBrush sculpt is like watching a 4K Blu-ray on a tube television from 1985. You're just throwing away the detail you worked so hard to create. So fidelity first? Think Shapeways. Think Sculptio. But what if fidelity isn't the priority? That brings us to the second point of our compass, function. This is about what your part does. Is it a gear that needs to withstand torque? A drone arm that has to be both incredibly strong and lightweight? A case for your Raspberry Pi that needs to resist heat from the processor? This is the world of engineering, not just art. And in this world, material properties are king. A beautiful high-fidelity resin print of a gear will shatter the first time you try to use it. It's brittle. It's not made for mechanical stress. When function is your priority, you're looking for a service that offers a massive catalog of engineering-grade materials. You need nylons, carbon fiber composites, ABS, polycarbonate. This is where Xometry and CraftCloud shine. Xometry, with its industrial backbone, lives and breathes functional parts. They provide detailed datasheets on material properties like tensile strength and heat deflection temperature. They understand that for a functional prototype, the performance of the plastic is the entire point. CraftCloud, by tapping into a global network of print shops, gives you access to a staggering variety of these same materials, often from suppliers who specialize in things like high-strength FDM or SLS printing with nylon. So, if your part has a job to do, if it needs to bend without breaking or hold a screw without stripping, your compass is pointing directly at Xometry and CraftCloud. This brings us to the final, and for many of us, the most important point on the compass: finance. Let's be honest, this is a hobby. We're not typically working with corporate budgets. The cost of a print can be the single biggest factor in whether a project even gets made. This is where you have to ask, is this a one-of-a-kind, money is no object passion project, or are you trying to make 50 of something as cheaply as humanly possible? If you are in the cost is literally the only thing that matters camp, there is one name that stands above all others: JLC PCB. They are a force of nature in the electronics world for cheap circuit boards, and they've brought that same ruthless, high-volume, low-margin efficiency to 3D printing. If you're prototyping, iterating on a design, and you know you're going to print 5, 10, or 20 different versions, the cost savings at JLC PCB aren't just a small discount. They can be the difference between finishing your project or abandoning it. A part that costs you $40 at a US-based service might cost you $6 from JLC PCB. The trade-offs are real. The shipping will take longer, the material selection is more limited, and the interface is less polished. But for raw, unapologetic bottom-dollar pricing, they are in a league of their own. So let's put the hobbyist compass into action with a few real-world scenarios. Scenario 1. You're a Dungeons & Dragons player. You've spent weeks digitally sculpting the perfect, custom miniature of your character, complete with the flowing cape and an ornate sword. What do? Let's use the compass. Fidelity is your #1 priority. You need to see every tiny link in that chainmail. Function is almost zero, it just has to sit on a table. Finance is a consideration, but you're willing to pay for quality. The compass needle swings hard towards fidelity. Your best bets are Shapeways or Sculpteo. You'll choose one of their high-detail resins, pay the premium, and a few weeks later, you'll receive a model that will be an absolute joy to paint. Scenario 2. You're an RC enthusiast building a custom racing drone. You've designed a new camera mount that needs to survive high-speed crashes. Let's use the compass. Fidelity is low. A few visible layer lines don't matter. Finance is medium. You don't want to break the bank, but it needs to work. Function is everything. The part must be strong, slightly flexible to absorb impact, and light. The compass needle points directly at function. You should immediately open up CraftCloud and Xometry. On CraftCloud, you can compare prices for nylon or carbon fiber nylon from different suppliers. On Xometry, you can get an instant quote for the same materials, confident in their industrial-grade quality control. You'd probably choose a material like SLS nylon or FDM carbon fiber PETG, and you'd get a part that can actually do the job. Scenario 3. You have an idea for a small product to sell on Etsy. A uniquely shaped headphone stand. You need to print a few different versions to get the design just right before you commit to making more. Let's use the compass. Fidelity needs to be good enough, but not perfect. Function is minimal, it just has to hold headphones. Finance is the absolute top priority. You need these prototypes to be as cheap as possible because you might throw half of them away. The compass needle swings hard to finance. This is a textbook case for JLC PCB. You'll upload your file, select their basic resin or FDM plastic, and order 3 slightly different designs for less than the price of one from another service. You'll wait a bit longer for shipping, but you'll have saved a huge amount of money in the critical prototyping phase. See how it works? Instead of getting overwhelmed by options, you start with your project's core need: fidelity, function, or finance, and it immediately clarifies your choice. But I want to leave you with one final bonus option. The one that's not on our list of 5, but might just be the most important of all, especially when you're starting out. And that is your local option. I'm talking about a local library, a university makerspace, or a community workshop. Many public libraries in the United States now have 3D printers available for public use, often for just the cost of the plastic, which is pennies on the dollar. A makerspace gives you access to not just printers, but a community of experts who can help you when your print fails or your design has a flaw. This isn't an online service, but it's the ultimate expression of the hobbyist spirit. It's the fastest option. You can literally have your part the same day. It's almost always the cheapest. And most importantly, it teaches you the process. You'll learn how to slice a model, how to level a print bed, and how to troubleshoot a clogged nozzle. These are skills that make you a better designer and a more informed consumer when you do go to use the online services. So before you click order on any of these websites, do a quick search for 3D printer near me or makerspace in my city. You might be shocked at what you find. Ultimately, the world of 3D printing is about empowerment. It's about having an idea in your head and, a few days later, holding a physical version of it in your hand. It's a kind of magic. And these services are the wizards that make it happen. There is no single best one. The best service is the one that gets your project off your screen and into your life, in a way that respects your art, your engineering, and your wallet. By using the Hobbyist Compass, by asking yourself if this project is about fidelity, function, or finance, you can cut through the noise and make the right call every single time. You now have the knowledge and the framework to bring your ideas to life. So the only question left is, what are you going to make first?